All right, so here again, Unit 2 Dynamics, yet another application of Newton's laws, and now we're going to focus on inclined planes. Okay, so remember, inclined plane is just simply a ramp. So up until this point, only thing we've been focusing on are when the surfaces are horizontal. Now we're going to take that surface and turn it up, right? And so we're going to talk about like what happens when it's the surfaces are now going to be an angle, and we call those inclined planes. Okay, another way of thinking inclined plane, it's just simply a ramp. Okay, so these problems are going to be interesting because gravity will be the accelerating force. Okay, but one thing to note: the acceleration is not going to be vertical; it's actually going to be in the horizontal direction. For problems like this, the positive x-axis will always direct it down the incline. Okay, physicists will do this and will to make problems easy on themselves, so they don't have to worry about like multiple forces and angles. By directing it down the incline, there's only one force at an angle. Okay, and that will happen to be the weight. Okay, and the weight force will break down to be, you'll have an x component, which will be mg sine theta, and then you have a y component, which will be mg cosine theta. So it goes against what we've been talking about with trig, with x going to the cosine and y going to sine. So it flip-flops because of the angles that you know. And so what does it mean to go down the incline? So this is what we're talking about. This is our physical situation. So we're saying positive x is down the incline, positive y is up, is off the incline. And so what happens is all the forces will follow that incline except for one, and it'll be our weight vector. Okay, so when we look at it here, here's the weight vector, right? It hangs out, just points straight down. And again, there's those two equations, your x and your y. These angles do match up. The angle of incline is the angle that the vector makes with the vertical there. And then normal force, again, it does originate from the surface, but when we draw our free body diagrams, we just basically connect these two. So I would have a normal force going off that way. I would have Fg down. But again, positive x, positive y, which means the only force that will accelerate the box down the incline is the x component of the weight. Okay, so let's look at an example. This is almost just like a general equation. So you have a box, basically the same picture that we just saw on the last slide, talking about a smooth friction of the surface. We're determining the normal force, determining the acceleration of the box, and then we're going to say, okay, evaluate for a mass of 10 kilograms and an incline of 30 degrees. So we're going to go and find the normal force and the acceleration for those values. All right, so again, here's our picture. Normal force coming off, weight going down. Right, again, here's our coordinate system. So that would be what I would put on my AP scoring sheet. But what I can do, right, what I'm going to do is we'll have an X piece here, or a Y piece, and then an X. So that'd be FGX, FGY. So what I just drew in red, you don't want to put on your AP tests, right? Because those are the extra forces that they don't want on the test. Again, I like to do T-charts. Okay, so I would do the sum of the forces in the y direction is going to be equal to 0, right? We're not accelerating it like this. We're accelerating it like this. And so I have two forces. I have my normal force, which sticks up. I have my FGY, right, which goes down to the angle, and it's going to be equal to 0. And so my normal force is just going to be FGY, which is going to be mg cosine theta, right? And so there's my expression, or my derivation, for my normal force. Now in the x direction, I'm going to do sum of the forces in the x direction. Now this is going to accelerate down the incline. So I'm going to set it equal to m times a. The only force I have acting is FGX. Okay, and I know that the equation for FGX is mg sine theta. But notice what happens. Same mass, and so my acceleration down the incline is just going to be g sine theta. So if you've done anything with acceleration with things going down an incline, you could actually find G knowing what the angle, if you know what the angle is. Now I'm going to evaluate for my normal force for a mass of 10 kilograms and an incline, or find my acceleration of 30 degrees. So now I'm just going to plug in my numbers. So I'm going to say 10 times 9.8 times cosine 30, right? And it's going to give me a normal force of 84.9 newtons. Okay, which happens to be the y component of my weight. And then I'm going to do my acceleration. So it's going to be 9.8 times sine 30. So notice the only thing I needed to know was the angle. Okay, so my acceleration is going to be 4.9 meters per second squared. And that'll be a positive because we're going down the incline. Okay, again, we're still working on applications of Newton's laws. In the next video, we will be talking about connected objects. Friction